Hey everyone, so this is the video number 3 in the computer networks and internet protocols. So in our previous video we have covered the what is the internet network edge and the network core topics. So in this video we are going to cover 3 topics: delay, loss and throughput. So this video helps to give you the overall concept overview of these 3 topics. So let's start with the delay. What is meant by delay in computer networks? Delay is nothing but the time it takes for a data or a packet or a message to travel from the source to the destination. It is also known as the latency. So we are very familiar with the word latency, right? In simple, it's just the time it takes to reach for a message from the source to destination. Delay directly affects how fast the communication feels to the user. So delay or latency plays a key role in the communication process. Delay is based on many factors like distances, bandwidth, hardware, and network congestion. Delay is of 4 types. So you can understand the 4 types of delay in this particular diagram. So if you want, you can also draw this diagram in the exams, but most often it is not necessary. There are 4 types of delay. They are processing delay, queuing delay, transmission delay, propagation delay. So let's discuss each one. First one is processing delay. It is the time taken by the router or a host to process a packet, including checking header information, errors, and decide where to send the packet. This delay depends on the speed of processor and it varies from computer to computer. So it doesn't have any formula. Processing delay doesn't have any formula as it depends on the speed of processor and it varies to computer to computer. The second one is queuing delay. It is the time when a packet spends waiting in a router's queue or buffer before being processed or transmitted. So it gives the waiting period time. A message or a packet waits in the buffer. This delay increases with the network congestion. Queuing delay depends on various factors like size of queue, number of packets arriving, etc. So it doesn't have any formula. We can't calculate in general. The third one is transmission delay. It is the time taken to push all bits of a packet into the network link from host to transmission medium. Let's understand transmission delay with an example. If B is bandwidth, usually bandwidth is measured in bps, that is bits per second, and L is the size of packet in bits. Then the transmission delay is L by B. Here L denotes the size of packets in bits and B denotes the bandwidth. You can also understand with the help of this diagram. So the last one is propagation delay. It is the time taken for a signal to travel through the medium. Medium is nothing but from sender to receiver. If D is the distance between sender and receiver in meters, then S be the propagation speed of the signal in Mbps. Then S be the speed of signal in MPS, meters per second. The propagation delay can be measured using D by S. Here D is referred as the distance between sender and receiver and S is nothing but the propagation speed. So it is a simpler representation for you. If you want, you can also understand with the help of this one. So if you want to calculate the total delay at any one router or a node, it can be calculated with this formula. The total delay is equals to processing delay plus queuing delay plus transmission delay plus propagation delay. So that is about everything of delays. what is mean by delay, what are the types of delay, and etc. So let's move to the next topic, that is loss. Loss occurs when one or more data packets traveling across a network fail to reach their destination during transmission, which leads to incomplete communication. It is also known as packet loss. A loss or a packet loss has several causes like network congestion. Overloaded routers and switches cannot store all the incoming packets, leading to the dropping of new packets as the buffer is full. Network hardware. Old and outdated network infrastructure can slow down the network traffic enough to cause packet loss. This can happen to firewalls, routers, etc. Software bugs. Outdated or buggy software on network devices or endpoints can lead to packet loss. Insufficient bandwidth. Due to the network's capabilities of insufficiency, it can't handle the data, so packets may get dropped in between the communication. The loss of packet or packet loss can be measured using this formula. Packet loss rate equals to number of lost packets divided by total packets cost into 100%. So you can understand with this example. Consider there are 1000 packets and 20 are lost. Then the packet loss rate can be calculated using then the packet loss rate can be calculated in this way. 20 by 1000 into 100%. If you calculate, you will be getting answer as 2%. So what are the impacts of loss or packet loss? Lack of communication quality. The communication quality reduces. Reduced network performance. The network performance decreases due to the loss or packet loss. Incomplete data. So when a packet loss occurs, the data transmitted from one end to another end gets, so some part of the transmitted data gets dropped in between the transfer. So the receiver won't be getting complete data, he will be getting the incomplete data. Packet drops. And the next one is poor quality audio and video. It is similar to the incomplete data. The quality won't be up to the point. So what are the actions or activities to do to fix the packet loss? Increase the bandwidth. Bandwidth plays a key role in the packet loss. So we have to increase the bandwidth. Improve network infrastructure. Upgrading or updating the infrastructure or the tech stack which we use in network communications. Update and upgrade software and hardware. We have to be using up to date softwares and hardwares. If the software or hardware are outdated, then we need to replace them with the new ones. Use wired connections. Usually wireless connections are better for transfer and reliability and consider space constraints, but wired connections are safer. Perform deep packet inspection. Throughput, the last topic of this video. The rate at which the data is successfully delivered from source to destination over a specific period of time and over a network. It is measured in bits per second like BPS, Mbps, kbps, etc. It considers the delays, losses, retransmissions. It is different from bandwidth. The throughput is basically of two types. That is instantaneous throughput, the rate at which the data is received at a particular moment. Average throughput, the average rate of successful data delivery over a longer period or longer time period. Factors affecting the throughput. There are various factors which are directly impacting throughput by reducing the amount of data that can be successfully reaching the destination. So the factors are, first one is bandwidth. In a limited bandwidth, too many devices compete with each other for delays, packet loss, and reduced throughput. Packet loss. Packets which are lost in transmission or errors never reach destination leads to reduce in overall throughput. Protocols overhead. Headers, acknowledgements, control packets consume part of the capacity. Bottlenecks. Link with slowest transmission rate in the network path that act as a bottleneck. It limits the total data be transmitted. Latency. High latency also lower throughput as it increases the overall time for data to arrive. So I hope you have understood the topics which I have covered in this video. These are very small topics. You can also get various videos about these topics in detail, but this much information is enough for these university exams. So that's it for this video. Keep learning.